when it is just suspended, then this is our baseline. So when it is in a baseline, all of you remember, so the always the potential energy is equals to 0. So when it is in baseline, okay. So now when the body has been such equilibrium, so remember, whenever you find a word called as allowed to fall, means in the sense of body is not in what? When it is allowed to fall, body is not in. Yes, please. What is that? No equilibrium. Keep it in mind, equilibrium is different. Equilibrium means extension. So there is a elongation of spring so that it will be weight. But here allowed to fall means in the sense of body is already removed from the spring. So that what will happen? The spring will goes up and down. Am I right? Everybody clear what I'm saying? It will be started going up and coming down. Am I right or wrong? Yes. So
Yes,
now while you are studying the spring, you might be remember either the spring is compressed or spring is elongated. Always work done by it is positive, negative. Aswita, what happened? Everybody. Work done by the spring is always we used to consider something positive.
Positive.
Always positive. Either it is compressed or by elongation. Work done by the spring is always what? Everybody?
Positive.
Positive. So keep it in mind then. So now here, there is no external force, there is no friction. So we have to find what is the elongation of the spring. Elongation of the spring means how much it is. What is that elongation of spring? To allow to fall. Yes, please. X. So let us see how to find it. So we all knows that if the body is there, something which is acting downward direction, weight of the body. What is that?
Weight.
Yes, please. Mg. And there is a force which is acting in direction. What is that?
Spring.
Spring force. Understanding? That is what K. So now if you take what is the formula? No friction. So we use second formula, first formula. Second formula. Okay. So Ki plus Ui. So all of you observe kinetic energy initial. What is that? No body is moving. So that kinetic energy is what? Initial kinetic energy.
Zero.
Initial potential energy also baseline. Baseline it is. No elongation, no extension. So initial potential energy is also what?
0.
Now, body has been reached to certain point so that no motion. It is ready to fall. So that no motion. So that final kinetic energy is also what? No problem, Asita. Focus on work. So body is ready to fall. It is already ready to fall. So that body position is already reached to extension. So that it is ready to break. So that what is the final kinetic energy? It's already came to final point. So that kinetic energy is what? It came to rest. Then it will ready to fall. So that what will happen? Final kinetic energy. See, for example,
0.
from here to here, it is the maximum point. It is already reached. After that, it will breaks. So that here also, what is the final kinetic energy? It's already came to
0.
point.
0.
So final kinetic energy also becomes 0. Now only final potential energy. That is only very important. So can you tell me what is the final potential energy? All of you observe very carefully and tell me. So what is that? Final potential energy. Anybody? Two things. One is spring. So when it will ready to break, all of you observe very carefully. When it ready to breaks, two forces it is acting position. Spring will go up. The force, the potential energy of the spring will go up. The body will come down. So all of you observe very carefully. This force is acting upward direction. That is what? The displacement. The displacement will go upward direction and the body is moving downward direction. Both are perpendicular to each other. So that work done by the body is what? Mgh or minus Mgh?
0.
Hey, body is falling downwards, Rudreswa, and the displacement of the spring is upward direction. So that what is the potential energy? This is Mg and displacement is upward. Then work done by that. Yes, please. Potential energy is equals to what? By that time. Mgh. M into G and displacement, the spring will go up as it is allowed to fall. Am I right or wrong? If it is allowed to fall means the spring will breaks, so that the spring will go upward direction, the body will go downward direction. So that what will happen? What is the angle between them? Yes, please. Displacement. See, applied force is backward direction, displacement is forward direction. So what is the angle between them?
180.
180 degrees. Means what is the work done? Work done is negative or positive?
Negative.
Negative. So that it will come minus Mgh, but still there is another force, spring force. The spring force is also, the spring is started moving upwards. So what is the potential energy of the spring? Anybody? Final potential energy of the spring, half into K into x square. So the spring will goes up. This is only confusing. When you solve one or two sums, you'll be understanding that. The spring will goes upwards. The potential, the final potential of the spring is half K into x square minus of the body goes downward direction as the spring goes upward direction. So that the work done by the body, gravitation, which is equals to minus mgh. That is what? Minus mgh. So that is what is the final potential energy of the body. So half kx square minus mgx is equals to 0. So which will turns into what? Half kx square is equals to mgx. Both the sides you can see something will get cancelled. X and x will get cancelled. So 2 will come this side. So kx is equals to 2mg. X is equals to what? 2mg by K. That is the answer. So x is equals to what? Once you solve next sum, you will be understanding. You see that. So there is a confusion in potential energy. If you are having confusion in potential energy, just wait and you can see that if a similar sum if you solve, you will be able to understand it. So what is the answer for this? 2mg by K is the answer. So that is what the elongation, maximum elongation of the spring. So now let us see that. Just hold it and you can see that question number 3. If you solve this question, you will understand. So there is a rigid surface where the pulley is attached. All of you observe. And this side there is a spring. Okay, there is a spring. And this side the mass M is present. Now all of you observe here. Now I will explain you this question. Same thing. So we have to find, if I consider this is the baseline. So if it is a baseline, something is 0. What is that? Initial potential energy is equals to what? Everybody. Initial potential is equals to what? Baseline.
0.
Now, after a certain time, just imagine that. I will use different colors and you can make it. That's what imagination is very important. So now, you imagine that there is an extension. Like again, I will redraw the diagram. All of you check it. I will redraw the diagram. The body M has been, from the baseline, the body M has been displaced some x meters. Elongation is x meters. Means the spring is also goes how many meters above from the baseline? Yes, please. It is also moves from x meters above. Am I right or wrong? Will you all agree with me? Yes, please. If the body is, this M body comes down x meters, means the spring is also goes above from the baseline x meters. Is it right, Rutushla? Clear? Understand? Yes. So now same question. So always remember one thing, the spring force, the spring potential energy is always what? Whatever it is going up or coming down. Always the potential energy of a spring is what? The potential energy of a spring is always considered positive or negative? Always it is positive. Now we want to find what is the elongation. All of you observe, it's very similar sum like that. Now what is the formula? No friction. So which formula will you use it? Final kinetic energy plus final potential energy, which is equals to, what is that? Initial kinetic energy plus initial potential energy. So we all know that initially body is not moving, so initial kinetic energy is 0. At the baseline, initial potential energy equals to also 0. Once the body is ready to fall, again same question, allowed to fall. So allowed to fall means already body reaches to what? Maximum distance is already covered. Am I right or wrong? Yes, please. All of you. So elongation of spring, like same thing. Suppose see, if this, all of you observe, if the spring is here till here, if I stretch from this point to this point, that is what equilibrium. Okay. If I stretch till here, the spring is already broke, so that the body is already fall freely. So it is already reached to the maximum point. Then only it is allowed to fall. Means in the sense of what is the final kinetic energy is also. Final kinetic energy will become, it's already came to break. So that what is the final kinetic energy? Already maximum distance it is traveled. 0. So that final kinetic energy is also will become 0. Now only initial kinetic energy observe very carefully. Now all of you see that the spring is going upward direction as the body breaks. So body is going downward direction. Now check it. This displacement is upward direction, body going downward direction. So that work done is equals to how much? Please, that you tell me alone. What is the work done is equals to? Work done is equals to negative. Am I right or wrong? Force is mg, displacement is x, and both are minus. So that it will 180 angle. So 180 means it is cos 180. So which is equals to minus mgh. This is all you understand, everybody? Yes?
Yes, sir.
Yes. Now, so that is what the final potential energy of the body. What about the spring? The spring is going upward direction. Of course, the potential energy of the spring is equals to how much? Half into k into x square. Actually, both are addition. That is what final potential energy. So final potential energy is equals to half into k into x square plus this one is what? Minus mgx, which is equals to 0. So it will turns into what? Half into kx square is equal. This is plus into minus minus. Am I right or wrong? Do you all understand, everybody? Yes? So that is what? So minus mgx, which is equals to 0. So again, same will come. What is the elongation of that? Half kx square is equals to mgx. So xx will get cancelled. So kx is equals to 2mg and x is equals to what, everybody? 2mg by what? K. Understand, Amma? So that's all it is. So this final kinetic energy alone, be very careful. When the spring breaks, when it's allowed to fall, body travel downward direction and the spring is started bouncing up and down. Am I right or wrong, guys? The spring will be fluctuate or not. If the body breaks, the spring will come down and go up, come down and go up. Am I right or wrong? Everybody? Yes? So that is what? So the final potential energy is equals to, the spring is compressed, either compressed or elongation. Both the cases it will possess what energy? Spring. Compressed or elongated. Both the cases it will possess some energy. Anybody? We already studied. What is that? If it is compressed or elongated, the spring possesses energy. What energy? Kinetic energy or potential energy? No response.
Potential.
Potential energy. Remember, due to the state or position, today only I told you, due to the state or position, the energy possessed by the body, we used to call as what? State or position, we used to call as potential energy. Due to the motion alone, we used to call as what energy? When the body is in kinetic energy. Due to position or state, like compressed or elongation, these all are types of potential energy. That is what? Due to the gravity, see here, you might be having a doubt. Sir, why, sir, you are taking two? See, potential energy is two types. What is the two types of potential energy? Anybody? One is gravitational potential energy. Another one is elastic potential energy. Now, the body undergoing gravitational potential energy. So body is displacing downward directions. Body is moving downward direction. That is what? Weight. Weight is acting downward direction. The displacement of the spring is upward direction. So that angle is 180. So that work done is mgh. Now the spring is also elastic potential energy. So elastic potential energy of the spring is equals to how much, Ra? Elastic potential energy of the spring is equals to how much? Half k x square. Understanding? If the spring will go up or down, doesn't matter. Always the elastic potential energy is what? Always it is. Always what it is? The
Positive.
spring potential energy is always. Here you see that.
Positive.
Always positive. Keep it in mind. The spring potential energy is always positive. That is what you have to remember. Okay. So let me take some more time now. Let me finish. One of the beautiful and toughest question I'll teach you so that you all will get an idea. Then we'll be finished it. Okay. So try to understand the question. Redraw the diagram. If you understand this question, most of the concept what we studied on today's class, we can revise it. Okay. So there is a surface now. So by the surface itself, I can say that. What is the potential energy? I am taking surface. So baseline it is. So what is the potential energy? Work done by the gravitation. Gravitational potential energy equals to what? Baseline, guys, it is
0.
0. Okay, this is not the question. Question I am explaining directly with you. So it is a rough surface. So if it is a rough surface means something is acting. What is that?
Frictional force.
Frictional force. So have an idea? I will draw. So there is a spring. All of you remember. And the spring constant is equals to 50 Newton per meter. What is the spring constant? Everyone? 50 Newton per meter. and there is a one attached object which is 1 kg. What is the mass of the object? Mass of the object is how much? 1 kg. Understand, Yama? Now, all of you observe, this is not the actual length of the natural length of the spring. Natural length of the spring. If I release the spring, basically see, if I release the spring, if I keep the natural length, this is what the natural length of the spring. As due to attached 1 kg mass, the spring length has been reduced this much. Do you understand, brothers, what I am saying? Because of 1 kg mass, the spring length is reduced this much. So, how much it is reduced means 2 meters. How many meters? All of you? Yes, please. 2 meters. Means if I remove the 1 kg body, then the spring will be up to this distance. Do you all understanding, guys, what I'm saying? Everybody? Yes. If I release the spring, if I remove this 1 kg body, naturally the spring length will be up to what point? This point. Do you understanding, all of you? Because of attaching 1 kg mass, the spring length, the spring has been compressed. How many meters? Yes, please. How many meters inside? 2 meters.
2 meters.
So it is compressed. So which energy it is possessing? Potential energy or kinetic energy?
Potential.
Potential energy. So initial potential energy is existed or not? Anybody? Initial potential energy is existed or not? Everybody, will you say that? Yes or no? No. It is compressed, girl. Initially itself it is compressed. So initial potential energy is not existed. See, the body is a compressed. Compressed means that it is possessing which energy? Elastic potential energy. So that it is compressed already 2 meters. Actual length is up to here. You write it here. What is the natural length of the spring, everyone? Natural length of the spring is up to this point. But due to attaching 1 kg mass, the spring is compressed how many meters?
2 meters.
2 meters. So this spring is possessing initial potential energy or not? That is what is my question. Everybody. Yes, please. It is possessing initial potential energy or not?
Yes,
That is what I'm asking. Yes or no?
Yes, sir. Yes,
So
sir.
now the coefficient of friction is 0.5. So means it's already existed. Friction is already existed as the body is moving forward. Now my question is, I want to bring from this point, from the natural length to some other point. So this point I should bring it. So what is that x? So we have to calculate it. What is that elongation of the spring to come to this point from the natural length? Okay. So if it wants to reach to this point, what is the total distance it needs to travel? Anybody can tell me? What is the total work done by the force? It needs to reach to this point. What is the total work done by the force? Distance. What is the distance traveled by the body? Anybody can tell? From the figure, you can observe and tell. If I am at this point, I want to reach this point. What is the total distance traveled by the body? Everybody. Yes, please.
X plus 2.
2m.
X plus 2 or 2 plus x. Am I right, everybody?
Yes, sir.
That is what. So it is a rough surface. So as it is rough means which formula we have to use it? First formula, second formula? Yes. First formula. The question is, at what distance? At what distance the block stops? The block stops. So the block stops in the sense of it is already reached to what? Maximum length. Maximum extension is over. So if you try to extend more further, what will happen? Like before cases, it will be breaks. Am I right or wrong? Everybody, please respond, Ram.
Yes, sir.
At what distance the block will stops? Means maximum I stretched it so that it has been traveled. At this point, maximum stretched it so that at this point it will be stops. More further extension won't be takes place. So if I try to extend more further, what will happen? The spring will breaks. Am I right or wrong? Everybody?
Yes, sir.
Yes?
Yes, sir.
Now I try to apply some force, like some force is exerting. So all of you remember, as I told you, 80% of cases, the external force is what?
0.
Made by it, 0.
0.
It's nothing, guys. Just imagine this question is like, imagine Mr. Everybody. So Mr. Rudreswar is, for example, I'm saying, Mr. Rudreswar is standing here. He attached 1 kg body and he pressed 2 meters inside from the natural length and he released it. He released it. So that automatically the spring, if you press it and if you release it, definitely the spring will travel some distance. Am I right or wrong?
Yes, sir.
That is only they are asking. What is the, at what distance the block stops? That is only we should find it now. Do you all understanding what I am saying, everybody? Yes? All of you?
Yes, sir.
Yes. So
Yes,
now,
sir.
let us see what is the first formula we have to use it. Work done by external force plus work done by frictional force, which is equals to, what is the formula? Final kinetic energy plus initial potential energy minus final initial kinetic energy plus initial potential energy. Am I right or wrong? Yes. So as we all knows that no external force is acting, so that work done by external force is equals to what? Yes, please. 0. Now, work done by frictional force, we have to find it. So if you want to find work done by frictional force, first you have to find something. What is that? Anybody? What is the amount of friction? Am I right or wrong? Yes, please.
Yes, sir.
So what is the amount of friction formula? Limiting friction. Mu into N. So mu into N means, what is the body? Body is 1 kg. So that weight acting is how much? Mg. Understanding? Up is normal. So N is equals to Mg. So what is the answer? Mu value is 0.5 into M value is 1 into 10, which is equals to answer, please. 5.
5.
Understanding? So what is the frictional force is equals to how many newtons?
5 Newton.
5 newtons. Now to see, observe,
5 Newton.
the force is acting backward direction, but the displacement is forward direction. So work done is negative or positive? Work done by frictional force is always. Work done by frictional force is body is
Negative.
going forward direction, the force is accepting backward direction. So work done by the frictional force is always what? Negative or positive? Minus Fs. Understanding?
Negative, sir.
Minus Fs. F means what? 5 Newton. That is what? F friction. Understanding? And displacement. What is the displacement? Can you tell me? Total displacement is how much? Check it, everyone. 2 plus
2.
2 plus
Sir, 2m plus 6.
2 ml. 2 meters per those are 2 meters. Okay. So 2 meters, 2 plus x. Am I right? Understanding? Everybody? So that's all. So work done by frictional force is equals to, now check it, everybody. So final kinetic energy plus final potential energy minus initial kinetic energy plus initial potential energy. So directly I can say initial kinetic energy and final potential energy. Already body came to rest. Maximum distance has been already traveled. 2 meters plus x meters. Already body came to this point. Then what is the velocity? Final velocity is what? 0. So final kinetic energy
0.
is also what? 0. Now, initially body is at rest. Velocity is 0. So that initial kinetic energy also what? Everybody? 0.
0.
Now, as it is in the surface, at the final point, the body comes to rest. So no height or no distance. So that final potential is equals to also what? Everybody? 0. Do you all understanding? Everybody, please respond. That's all. So work done by the frictional force, which is equals to minus 5 into 2 plus x, which is equals to final kinetic energy is what? Body already came to maximum distance. So final kinetic energy 0.
0.
Body is in same surface, ground. So ground means work done by the gravitational force. Already I have done here. Potential energy. Work done by potential energy equals to how much? Work done by potential energy. How much gravitational potential energy? It is in the same point, baseline. See that body comes to this point, imagine. So that work done by the gravitational potential energy is what?
0.
And already it is touched maximum. So that elongation, the another spring force is not existed. So that potential energy is what? Final potential energy. Everybody.
0.
Final potential energy equals to also becomes 0. And initially
0.
velocity is 0. So that initial potential is equals to also 0. Now only final potential energy. Can you tell me what is the final potential energy? Spring force, guys. Sorry, initial potential energy. It is pressed. It is pressed. So what is the initial potential energy? The spring is compressed. So spring is compressed means what is the potential energy? Compressed spring. Yes, please. What is the potential energy of the spring, which is equals to half into
Yes.
x square.
Yes.
X means what? X means what? Either elongation or
Compression.
compression. That's all it is. So what is the initial potential energy? Everybody? Minus of half kx square. So both the sides minus will get cancelled. And k value they have given something. How much it is? 50 Newton per meter. So which is equals to half into 50 into x square, which is equals to 5 into 2 plus x. Now, everybody observe very carefully. I can get cancelled. 5 ones are 5 tens are 2 ones are 2 fives are. So 2 plus x is equals to 5x square. Will you all agree with me, everybody? Yes. So quadratic equation 5 square minus x minus 2 is equals to 0. Can you tell me what is that? All of you, fastly tell me. Everybody should tell. So what will happen? Equations tell me, Ra. Minus x should come. 5. Any possibilities?
Sir, we have to put to part 1, sir. Minus 3 plus or
Yes.
Yes.
Equations not possible. 5 2 is a 10. 10 means 5 2 is a won't be possible. So what is that? Anybody? 10 possibilities so
Sir,
that it will come. Yes, Dreswa? Roots.
sir, formula only, sir.
Yeah, we cannot use it this. We have to use it complex roots formula. Am I right?
Yes, sir.
Yeah. So if you use complex roots formula, plus or minus what? B. Am I right?
Yes.
What is the formula that?
Sir, minus b plus or minus root over
Yeah, minus B plus or minus root over A square minus
minus
4AC. Yeah, minus B plus or minus root over B square minus 4AC divided by 2A.
2a.
Two.
So please use this formula. So whatever you will get it. So that is what is the x value. That's all it is. Okay. So please make it. So this is what is about this question. I hope you all understanding. So this is what about the only spring problems. Today I am teaching only spring problems. And tomorrow we will study inclined surfaces. Okay. So inclined surfaces is also one of the most important one. But here inclined surfaces also will consider what? Actually, no inclined surfaces is a frictionless surface. But for solving numericals, we'll consider as a what? Yes, please. All of you. Inclined surfaces with a zero friction. So zero friction means what? It is a smooth surface or rough surface? Frictionless surface. Okay. So always for 11th physics, 90% cases, the external force is 0 and frictional force is also 0. If it is friction is existed here, as it is friction is existed, they mention rough surface. So that is why we are taking first formula. So here all of you observe, again I'm saying, when the body is already came to maximum distance, velocity is 0, so kinetic energy is 0. Body is in the same surface, so potential energy, final potential energy done by gravitation or whatever it is 0. Basically, it is the same baseline. Then as the Y's are initial kinetic energy is also 0 because body is at rest. Now, why is there only initial potential energy is existed? Because it is compressed by 2 meters from the natural length. Am I right or wrong? Everybody. Do you understand it? So it is a compressor means it is stored with some energy. What is that energy? Potential energy. So that is only elastic potential energy, which is equals to half kx square. I hope you all understand, everybody. So problems are very complicated. If you sit and solve only, you'll understand. So everything you have to solve it. This is one of the toughest problem from H.C. Verma book. So then tomorrow we'll see the inclined surfaces so that you all will get an idea. Most probably within 2 or 3 days we'll finish this chapter. Okay, then we'll go to the next chapter. That is what angular momentums and all will come. So rotational dynamics. Okay. So thank you everybody. We'll meet in tomorrow's class. I think already it's time up. You get sleep and wake up morning and be sincere in work. Solve regularly without fail. Wake up 5 o'clock. Still I am not feeling many people are wasting time. Show the dedication and make it happen. Things has to go well. Okay. Mr. Monish, Mr. Narayan, please together work and classroom also manage the time well and work together. Your combined work only makes you well. Keep it in mind that individually, if you try to work, impossible to improve the physics and whatever the subject for competitive exams. So work together and make your time maximum benefited. That is the only suggestion I can give you. So work kindly, properly. Okay. Thank you guys. You can get back to the sleep immediately and wake up morning 5 o'clock and 1 hour completely dedicate whatever your lifestyle. 1 hour must be go for a NEET and JEE preparation. Then only you can do something. Remember it always and work. Okay. Thank you everybody. Good night.